Yeah.
Okay, we are public. And now I need to find the URL.
I don't have it yet.
I hear some typing.
So welcome everyone to this week's virtual star party. For those who managed to jump right in, welcome to the part of the show where we all madly try and get everything live while fighting the demons of, well, in my case, Chrome freezing while you get to listen to me in Safari.
Type, type, type.
This week we're going to have a whole variety of people with us, from getting to see the sunrise over in Turkey to seeing the sunset in San Francisco. We just need to unfortunately get embed codes and things like that going. So once we have all of that, we will be good to go and you will have our full and undivided attention. In the interim, we'd invite you to tweet, share, embed, to follow along and help get this out to as many people as possible. So we're doing this as a labor of love, and it's going out to you via YouTube Live, via Google+, and via the CosmoQuest Hangouts. And we hope that you enjoy the show and will take the time to +1 it so that we know that you're out there, or drop us a tweet using the hashtag #CQX. So if you could let us know you're there, we'd greatly appreciate it.
I just checked, Pamela. You're live on CosmoQuest.
Thank you.
And as soon as we see one person +1 it, then we know we're live.
Come on.
I see a plus. I see a +2. I see +2, and I see a share. So that's good enough for me. All right.
Okay.
Let's do it. Okay.
We're good to go.
Okay. All right. Well, hi everybody. My name is Fraser Cain. I'm the publisher of Universe Today, and this is it's time for another virtual star party. We've got lots of really good stuff we're going to be doing this week. We've got live telescopes right now from 2 people, and maybe more joining us later. We've got Stuart, who is Stuart Foreman, who's in the San Francisco area, and he's got a live view of Venus right now. Can you say hi to the folks, Stuart?
Hello.
There we go. He's got his purple Venus going on right now. And we've also got Gary, who's in the LA area, and he's got that beautiful view of Orion right now. Can you hear us, Gary?
I hear you.
Awesome. Cool. All right. Now both of these objects, actually, we're going to be running out of them very quickly. So we wanted to quickly hurry and just give you a chance to see both of them right away, and then we'll probably try and shift to some other stuff as well. But we've got sort of some other stuff planned tonight. We've got everyone who doesn't have clear skies tonight is posed in front of their telescope, and I thought, what we're going to be able to do tonight is show off all of the different telescopes, all the gear, talk about how things are set up, the different sort of the way these telescopes are set up, the different camera setups, how everything's mounted. So we should be quite an interesting sort of educational evening as well. So now I'm just going to sort of introduce everybody in no particular order here. We have Ahmet Kale, who is in Turkey, and he's got a beautiful view. Actually, he's out in Turkey. It's actually morning now, so the sun's just come up while we've been preparing, and you can actually see his beautiful rolling Turkish hills there, and his great telescope there. And we've got Chris Ridgway. I don't know where you are, Chris, but we've got 2 telescopes in the background. And then we've got, of course, Gary, who has his guy's view of Orion right now. And we'll get some views of his telescope shortly. We've got Mike Phillips, who's over on the East Coast, Virginia or something. Where are you?
North Carolina.
Oh, you're muted, actually. North Carolina, that's right. And we've got your monstrous 16-inch home-built Newtonian telescope in the background there.
14
yeah,
inch.
Oh, is it 14-inch? Oh, sorry.
Yeah, that's okay. I wish it was that big.
Yeah. Yeah, and then and now Pamela's here to bring the science. So it's Dr. Pamela Gay from my co-host on Astronomy Cast. Roy Salsbury, who is normally broadcasting from his really cool desert hideaway in Arizona with his various telescopes, but he's back at home and he brought a telescope with him just to have it in the background. That's a Celestron. That's your 8-inch Celestron.
8-inch.
Yeah. Okay. Cool. And then Stuart, who is like I said in the Bay Area, and we'll be able to. At some point, once we start to lose Venus, I'm hoping we'll be able to get a chance to see his gear. Although he's, I guess it's getting dark there because he's actually outside. So.
I can shine a light on it. It's not that big.
Okay, cool. That would be great. So what's the now tonight? We've got to. It's some things are good, some things are not so good. Venus is still up, and as everyone has probably seen, it's very high and bright in the sky right now.
And it's not really purple and pink. It's really not. It's much closer to this color.
We only had a couple of choices, right? We had
Picky,
green.
picky.
Yeah, we had green and we had purple, and
this is false color.
Oh yeah, false color, exactly. But I think you really can see, some features. I mean, Venus is really hard to see normally because the whole planet is covered in this really thick cloud, and so there's no like surface features that you can even see. So the best you can really see is some sort of variations in the atmosphere on the side that's facing to the that's facing towards the sun. And I guess the thing that most people don't realize is that Venus looks like a crescent. It kind of looks like the moon.
It goes through almost all of the phases, actually, because as it goes from, I have toys this week.
Oh, good. Yeah, you brought props.
So trying to pull out, here we go, here's a good sun. So as it goes from being behind the sun, where it appears full, to then in front of the sun, well, when it's in front of the sun, we don't actually see it illuminated at all. So we get to see it going from full down to new, just like the moon. And as it does it, it gets to pass through a whole bunch of different gibbous phases. Now, it's very, very rare that we actually get an alignment such that Venus passes in front of the sun, but we are going to get that this June 5th and 6th, and you're all welcome to join me up in Anchorage, Alaska, which is predicted to have clouds. But I can't afford to go to Australia, so I'm going to Anchorage. So yeah, I know Fraser's going to be trying to view this as well.
Yeah, finally, something's going to happen where I'm able to see it.
I fixed the color a little bit on it, but yes, I increased the gain, so that got rid of the color abnormality.
Yeah, and so when Venus is at its brightest point, actually, that's when it's just about to sort of disappear in front of the sun, right? And that's so you can see in Stuart's image right now, you can really see that crescent view, and it will actually still get even more crescent-y, look more like a new moon, but get brighter as well. So yeah, it's a great time to see Venus. And unfortunately, I mean, we've been showcasing Jupiter month after month since we started doing these things, and now Jupiter is gone. We have lost Jupiter. Jupiter has been, I don't know if you've been watching, like we had that conjunction about a month and a half ago, and we could see Venus and Jupiter really close to each other, and then Jupiter just kept moving further and further to the west, to the horizon, and now Jupiter is only visible during the day. And so I guess it's going to pop out the other side, I guess, and start becoming a morning object, right?
Yeah, they're polite that way most of the time. It's just one of those things that as everything's moving on their little orbital racetracks around the sun, we lose things behind the sun, and then as they come out the other side, it's just a matter of which rises first in the day, and it's going to become a morning object when it comes out the other side. Comets do this all the time. That's one of the more frustrating objects, because just as soon as they get awesome and bright, you lose them into the sun, and you have to wait for them to become morning objects.
And then we've got Mars. So where's Mars? Mars is up right now, I think, for folks on the West Coast. So we'll probably try and
Mars
switch
is straight
to
up.
that.
I'll get Mars after.
Yeah, we'll switch to that, but we just wanted to get an image of Venus before we lost it tonight. And unfortunately, the moon, it was just a new moon just like 2 days ago or yesterday, which coincided with the Lyrids meteor shower, which was really great because whenever you get a meteor shower and there's no moon, then everything's a lot brighter, everything's a lot crisper and clear, and a lot of the more faint meteors are visible. So when you're looking at a meteor shower, you don't want the moon. But at the same time, when we're trying to do a virtual star party, we like to show the moon. So we're torn.
It's okay. It gives us a high contrast sky. That's the way to think of it. So when the moon's in the sky, it's like your background suddenly got white. And if you've ever had a TV where the black wasn't truly black, and you know how annoying that can be, that's what the moon does.
Yeah.
So get rid of the moon, and all of a sudden, all the blacks are blacker, and the whites appear whiter, even though they were really the same before.
Yeah, and so we'll get a view of Mars because we've got lots of time to be able to broadcast Mars. Now, where's Saturn for you, Stuart?
It's really still quite low. It is above the horizon right now, but to get to it, I would move out of Wi-Fi range because I have to move my telescope to the end of the driveway.
But if we're still here in an hour or so, do you think you'll get a higher view of it?
Yeah, we can try.
Okay, that would be
give it a
great.
shot.
Yeah. Yeah, and so, for anyone now, pretty much anybody who wants can see Venus should still be up for anyone on the West Coast, probably even sort of in the interior of Canada and the U.S. I don't know if it's still visible on the East Coast, probably down by this time. But Mars is that bright red star up in the sky, and Saturn is a little fainter, but it's off in the east, and definitely is up now for most of us. And
Fraser, do you want me to try to get Mars? It's going to take me a little bit to get it. But
yeah. If you could switch to Mars, that would be great. Goodbye, Venus. And
okay.
We'll switch over and take a look at what Gary's got, which is again one of the things we've been looking at every week, and this is going to be one of the last times that we're going to be able to see it until it goes down below the horizon. So that, of course, is the Orion Nebula.
And interestingly enough, if you see these shadows off to here, that's the tree it's starting to go behind.
So we really have like 2 minutes before it's gone.
Yeah, that's a 10-second exposure.
Right. So do you have time to do one of your longer exposures, or should we just move on to something else?
Let me see if one more 10-second is going to put me behind the tree.
Okay, all right. Now, where's the Horsehead Nebula right now? Do you think we could take a look at that as well?
Just above it. I'm going to that next.
Okay, let's do that. Yeah. Oh, there we go. Mike's got. Mike? Is that one of your photos of Venus?
Yeah, so I mean, we were talking about Venus and how it's featureless, so I thought I would show you one of the photos that I took. This subtle shading here is actually some of the clouds that you can see in the ultraviolet. So I have an ultraviolet filter, and the camera is sensitive enough to see wavelengths that we can't see, right? I'm sure Pamela can explain this better than I can. And I synthesized the color onto here, so just to... And you can actually look at, if you look at the difference between this one is from, let me see, when did I take this one? April 2nd.
Yeah.
And you compare that to where we are today on the 22nd with what Stuart has there, and you can actually see that there's a significant difference in phase already. So
it's stunning.
Yeah, it's beautiful.
I'm really, really impressed. What's kind of awesome is part of the reason that the edges are so white is you're actually seeing light pass through the cloud layer on Venus.
Okay.
That's not just something
where you get that white outline and it looks like someone set border to 3 pixels.
Right.
That's actually the
right.
atmosphere with the light passing through the atmosphere.
Oh, that's amazing.
I'm glad you told me that. I was angry at it. Sometimes, it's funny. I've seen this before. Sometimes you see these things in the photos and like it's not supposed to be there, right?
No, you did it totally right. It's fabulous.
Cool.
Oh, that's fantastic. And so, like, how long of a video would you have done to have captured that?
So that is in the ultraviolet. Believe it or not, is at this focal length that I usually shoot at. It's fairly dim. And so I think I must have recorded at like 30 or 40 frames a second, probably across at least 90 seconds. And then I used an infrared for the red channel, and then I synthesized the green to make kind of a false color image out of it. So I don't know if it's actually tan, white, and brown like you see here or not. But the infrared was probably another 90 seconds. And I've seen other people who've taken photos in probably better conditions that look nicer than this, and you can actually see the clouds rotate in the form of 30 or 60 minutes. So, in like about a half an hour or so, you can actually notice differences in the clouds' positions.
Wow. So when you say that you're using ultraviolet and infrared filters, the reality is that those are two wavelength bands that our atmosphere does a really good job at mostly blocking. Are you using a I filter and a U filter on the Johnson system, or what type of filter are you using?
I can't remember who the manufacturer is. It's called the U Venus filter.
Uh-huh.
It's actually in the filter wheel. Yeah. And I guess I can't necessarily answer your question, but we can look at it. It's you probably won't even be able to see Stuart with this camera. It's one of these ones here.
Cool.
This one, Astrodon.
Astrodon makes good filters.
It's highly reflective. You can actually see the camera.
You can see the camera, yeah.
No, that's
Because
one
it's
of the
visible,
crazy things about infrared filters as well. Is I remember the infrared filter, the I filter, that I used in graduate school. It had a highly reflective surface on it.
Green and the red. I'll have some reflectivity to it. But yeah, I've actually done that once with my eye, but I've never held the ultraviolet filter up to the camera. But yeah, it is very reflective visibly, and it is noticeably dimmer than the other channels in a monitor.
Well, and you're dealing with the fact that our atmosphere is doing its best to block infrared light from getting down to the surface of the planet. Now, it's not doing as good a job as it used to, which is good for astronomy and bad for sunburns. But nice, dry, high-altitude days are the way to do it. But you're doing it from the East Coast, and that's really awesomely impressive.
That's really cool. Well, let's take a look at some other gear as well while we're I'm not sure where Gary's at right now. It looks like he's still trying to capture some images of that.
That's the 60-second right there.
Okay, yeah. So you can really see I mean, again, I always love this because you see different things. When you do that 10-second exposure, then you get a really nice view of try to get towards the trapezium part of it, and then when you do that big longer 60-second exposure, you can really see the faint detail around the brighter part.
And this is all basically hydrogen gas that's being illuminated by extremely bright, hot stars that are embedded within the gas. And these are all stars that are roughly 10 times the mass of our sun or more. They're all going to eventually explode as supernova. Many of them are going to eventually become black holes. But right now, they're all young, and they're all packed together very tightly within this nebula. And over time, as they orbit around, they're going to get stretched and spread out. But you can imagine if that wasn't going to happen, the sword of Orion is eventually going to explode as supernova. And that's just kind of cool to think about, is an exploding sword. Now, the reality is by the time they start exploding 40 to 50 million years from now, all that star cluster will have been shredded due to differential orbiting velocities as they go around the galaxy.
That's great. All right, well, why don't we take a look at some of the other gear that we've got in the background. I think we'll come back around to Mike. So Ahmed, are you there? Can you hear us okay?
Yes, I'm here.
Okay, great. So
Here.
I've never actually seen your telescope, so this is fantastic. I'm really glad everyone was able to do this. I think this is really cool. So can you tell us what telescope are you using?
I'm using Celestron Cge 25, and it has a Cge Mount.
Right. So the 9.25, so it's a 9.25 inch telescope. So it's sort of a little bigger than that standard 8-inch Celestron that most people are familiar with. And you said it's got a Cge5 mount, is that right?
Yes, Cge5.
Yeah, and so that's the motorized mount that you can get for a lot of Celestrons. And then you're actually using your webcam right now, which is that you use you have a Canon, right? You have a DSLR camera, right?
Yes, T2i DSLR camera. I'm using for taking planetary images, and also as a webcam now.
Yeah, no, that's really great. And as we can see, you're about 12 hours or so ahead of me, or about 11 hours ahead of me. here on the west coast of Canada, and so you've got the sun's going to be coming up. You don't happen to have a solar filter on that, do you?
I have. Actually, I did my solar film yesterday. So I took some images and videos.
That's fantastic. And now, if people don't remember, we've got a little bit of history here. Back when we first started to do these virtual star parties, Amit was one of the first people that jumped on board, probably with the second or third one that we did back in, I think, November or October, November. And it was great because, I mean, he got up really early or stayed up really late, and while the rest of us were able to only see things like Jupiter and such, he was showing us the first views of Saturn that we'd never seen before in doing the virtual star party. So that was really great, and I'm really glad that you were able to show up.
I just love how well this is highlighting planetary rotation.
Yeah.
With the sun coming up in Turkey, we have the sun finally full enough set in California that we're able to get images coming from Gary and Stuart, and we basically are spanning the night from both sides of twilight.
Yeah. Yeah, and now we just need the southern hemisphere. So if anyone in the southern hemisphere is watching, we would really like to be able to see. I mean, it would be great to have somebody in, I guess, South Africa or Argentina, places like that, so we can get to see some southern constellations.
South Africa's daytime right now.
Yeah, that's why I was thinking Argentina.
So we need Chile, we need Brazil,
Chile, yeah,
someplace like that.
Yeah, that would be great.
Do you see my red blob?
Yes.
Yes.
Okay.
We see your red blob.
And that object I'll let you keep that color for. I won't mock it. It's still not right, but I won't mock it.
No, that's fantastic. But I can't see the polar ice cap.
Can you drop your gain a little bit, maybe?
Sure. Hang on.
It's
So
shrunk
gain,
tremendously.
it's just like on an old style.
Yeah, it's a lot harder to see now.
So if any of you remember the old style televisions with the knobs and the rabbit ears, there was a gain button, and when you turned it, the picture got bright, and when you turned it down, it got fainter and fainter and fainter. Well, basically gain is a way of saying, I want to have, for every one piece of light, photon that's either emitted or, in this case, detected by my screen, I'm going to have a ton of electrons or very few electrons. So what he's doing is he's adjusting how many electrons get triggered for every photon that's hitting his detector. And if the gain is too high, you end up with a Mars that has no details. If the gain is too low, you have no Mars.
And you still have a Mars with no details, but, you know.
Well, it sounds like your skies just aren't quite perfect.
I think this is, I mean, it just darkened for him now, but I think this is a pretty representative view of what you might see if you look for Mars through a small telescope. I mean, this is what you see, and probably a little more detail than this. You know, you lose a little bit in the translation from the telescope to the webcam into the computer into the Hangout. We're losing a lot of detail here. We're doing the best we can, but. But I think this is sort of what you'll see when you look through a telescope.
Oh, wow, Amit got the sun. Look at that. It's amazing.
Well, this is some video that he did before.
Okay.
So
But
this
it's still
is
amazing.
To see the trees moving like that over the disk of the sun as the sun, I guess, moves behind the trees. That's really cool. I like that.
That is really cool, and you can see the sunspots on the surface of the sun there.
There is some birds on the trees.
No, it's very well shot. I think that's awesome.
I have total telescope envy.
Oh, that's phenomenal.
Wow. And you can even see the atmosphere down along the horizon side of the sun, and that's beautiful.
That's
Very
phenomenal.
amazing.
Have you? Well, I guess you probably couldn't stack it because of that tree.
Yeah.
Oh,
but look at the cluster of sunspots that just came out from behind those branches.
I feel, this is really cool. We tend to not like to try and show post-production stuff, but this is phenomenal.
Hey, Amit, how long was this video, though? This must have been tens of minutes long.
6 minutes.
6 minutes. Wow,
Yes.
that's awesome.
That's phenomenal. Well, why don't we move on here? So Gary's got the Horsehead Nebula, and so I thought we would take a look at that quickly.
That's Horsehead at 60 seconds. So as we've said before, this one star right here in the northern hemisphere is the left star of the belt of Orion. That kind of puts a perspective. The Orion Nebula we were saying is in the sword of Orion. Anything Pamela wishes to say, she knows a lot more than I do.
So this is basically a cloud of gas and dust, and where you see the Horsehead, that's what's called a molecular cloud. It's an area where the gas and dust is so thick that none of the light from behind is able to pass through it. Off to the left where you have the Flame Nebula, that's a group that's being illuminated by a bright star, and just happens to look a bit like a flame of gas if you have a gas stove. What's really neat to me about this is that's one of the bright stars in Orion on the left-hand side of this image. So when you go out and you look at the belt, you're seeing the Horsehead, and you're not seeing it because our eyes just aren't sensitive enough to this faint an amount of light. And it really gives you a sense of how much of the universe is just waiting to be discovered as we build bigger and bigger telescopes.
Yeah. That's great. Fantastic. Well, cool. So why don't we talk to Chris for a second here, Chris? So you brought 2 telescopes to this party.
Yeah.
So why don't you tell?
Right here, the one to the direct right of me is a Meade LX90 8-inch. It's got the advanced coma-free optics, and then the one behind me is a Celestron Astromaster, I believe. It's a 5-inch on a CG5 mount. CG3, I'm sorry.
So now, which was the first telescope? Was the smaller one was your first telescope?
Yes, this was my first one. The Celestron was, and then I promptly went from it to the 8-inch.
Yeah. and now you're scheming about a 16, right?
Yeah. My wife is actually scheming for me to get a 16-inch, or if she would have her way, it'd probably be a full-on observatory.
That's awesome.
That's great.
Don't fight that.
Yeah, great wife. But what's interesting as well is you can see the 2 different kinds of mounts actually in this view right now. So you've got the sort of equatorial mount, the CG3 on the Newtonian, and then you've got this fork mount on the LX90. So.
Right.
So what's the difference in those mounts? Why would you pick one over the other?
Well, the equatorial, you get a lot better control for pretty much anything you want to do. It's a little more difficult to use, especially for a newcomer. But your telescope will move, with the planet. It just kind of rotates around very easily. The fork is just altitude and azimuth. So it just moves up and down, left and right. This one here, I can actually twist it in any direction like this. And then, like I said, and it moves up and down, left and right as well. So it just gives you better control on the equatorial.
Yeah, I mean, when you're tracking objects, because the Earth is tilted 23.5 degrees, and so you tilt the telescope. Essentially, the telescope is tilted on its mount to match that tilt of the Earth, and so then you can just turn like one little knob, or it can use a motorized mount, and it will just track perfectly because it's just got one sort of dimension that it's having to move along. While with the fork mount, it's constantly having to kind of go a little bit over and a little bit down, a little bit over and a little bit down as it's trying to track an object in the night sky, which I don't know. I mean, with the really powerful computer-driven ones, it's pretty smooth, though, right?
Yeah, with this one here, the LX90 that I have, see if I can get it around here.
I mean, that's a beefy mount.
Barely see it. Right here, you'll see a little silver right down here underneath. This is actually a GPS. So this has, GPS on it. And that actually allows for better tracking. I've seen a lot of people I'm sure Gary and Mike both have their scopes on tracking. With this GPS, I was actually really surprised at how well it tracks right out of the box.
That's great. Now, and then for
for
you doing your, yeah, yours is an equatorial mount, right, Mike?
Yeah.
Yeah. Now, but Chris, for your camera setup, you're using a DSLR as well, like Amit, right?
Right.
And so actually, we can kind of see it here. So you've got a mount, an adapter. That's a T-ring adapter, right, on your telescope there.
Right here. I use a focal reducer, and then I use the T-ring and then the T adapter right here in the middle, and that just allows me to hook up just a regular DSLR to the back of the scope and take images. Just use the scope basically as a very large camera lens.
And so in this, very large camera lens. Yeah, exactly. I don't know what's it's a big telephoto lens on the front of that.
Yeah, because the focal length on this Schmidt is 2,032 millimeter focal length.
Wow.
And it's a 203 millimeter objective.
Fraser?
Yeah.
Excuse me. If you want, I can break this down, move my rig, and try to get Saturn for you. It'll take me about 10 or 15 minutes to do that, though. Would you like to?
Sure. Well, yeah. Why don't we, before we do that, and before you break your telescope, why don't we get a view of your telescope?
Okay. One sec.
You can switch to your computer camera, and then we can get a view of your setup.
Exactly. Hang on.
And while we're waiting on that, let's take a look at what Gary's got. What have you got, Gary?
This is the NGC 2264 Christmas tree cluster. It's a nebula area, and right over here is called the Cain Nebula. Now I'll turn it over to our expert who knows more about it.
So the Cain Nebula it's a hydrogen region. So this is part of space that most space is made of hydrogen. It's one of the sad realities of most of the time. It doesn't get more exciting than one proton and one electron happily flying through space bound together. And all of these hydrogen atoms, when they get heated up by the cluster of stars that's embedded within this gas, they get excited, and when the electrons move up and down the energy levels, they give off a variety of colors of light when they're coming back down. And in the visible light, which is the color that we see with our eyes and that Gary's focused on with his telescope, the brightest line that we're going to look at is what's called hydrogen Balmer alpha line, or H alpha for short. And this is just when the hydrogen gas is re-grabbing on its an electron, and that electron is making the jump from the third energy level down to the second energy level and giving off light in the shade of red that's the same shade of red as a neon open sign at your local deli.
That's great.
That about says it.
Okay, so Stuart. So now we've got Stuart's telescope here.
Okay, so what I have here is it's a 140 millimeter apochromatic refractor, and that's what this guy is here. This is just a spotting scope. Here, I just got a flashlight. Can you see it?
Yeah.
I've got it right now. I have a teleextender with 2x Barlow, and this is a flip mirror. And then I have my imaging source webcam down here, which is going to the computer. My mount is the Skywatcher EQ6, which is made, I don't know if it's made anymore, but Orion makes the same mount as this one. They call it an EQ-G mount. And it's their heavy-duty mount. But it's low end in terms of mounts. It's not like an astrophysics mount, which costs like $10,000. These run about $1,400. These mounts.
Yeah.
So and it's pretty good. It's not a fantastic mount, but it's good enough to hold the scope, and it's I'm reasonably happy with it.
Yeah. No. It's great though. I mean, you're the only person with a refractor. Everyone else has got a reflector tonight.
Yes.
And you've got the refractor of the team. So that's really cool.
And one advantage of the refractor is that the optics tend to be a little better than a reflector. Mike more than makes up for it by having a scope that's about 15 times the size of mine. But for bright objects, this is great. For dim objects, it's not so much.
So you haven't tried to
and
do
this
the
is one
deep
of the
sky with
things.
it, Stuart? Sorry, Fraser.
I was just going to say that we've really discovered sort of the different setups are better for different kinds of things, and so a lot of times, you're like Mike and Stuart. You guys both have really good setups for more of the planetary stuff, while Gary, for example, is better for the deep sky stuff.
Right.
But
you were going to ask me something, Mike?
No, I was curious because a lot of people, the way you got it set up there with, I guess, the piggyback finder there, I wasn't sure if you had tried to do any auto-guiding for deep sky.
Oh, I have an auto-guiding scope, and
Okay.
this is where the auto-guiding scope normally goes, right there.
Yeah, I see it. Okay.
Yeah,
Right.
but I just don't have it hooked up because I knew I was just going to be doing planetary stuff. But normally, if I'm doing deep sky stuff, I do have an auto-guider, and it hooks up there.
And Pamela, auto-guiding?
So,
Yes.
so this is the reason people are so concerned about what type of telescope mount they have is the Earth is rotating, but your telescope, it's not a matter of just moving at the correct speed. It's a matter of compensating for things like the amount of force that your gears have to deal with when your telescope is pointed straight up, and when it's pointed sideways with this huge lever arm is very, very different. So you have to be able to program your computer to compensate for that with pointing maps, but you also have to sometimes just deal with things like the wind and other stuff you can't program in fixes for. Your telescope ever so slightly left, right, up, down in order to keep that one star on that one pixel the entire time.
I dropped out for a second there. Oh, I'm back.
You're back.
Yay! This is so stable.
Okay, I'm gonna sign off and move.
Okay, well,
Okay.
thanks. All right, thanks, Stuart. We'll talk to you
We'll see
when
you on the other side.
when we
Okay.
see Saturn. All right, well, let's move along the crew here. So, Mike, now look at that beast behind you there.
I told one of the guys in the chat, I said, it's just an optical illusion, really. So I tried to stand
It's a
next to the
perspective thing, right?
thing. Right, yeah. It actually was behind me, so, and I'm about 6 feet tall, so most of this is just in the tripod, really. It's not all that big.
No, it's still a monster.
So it's a Celestron Cge Mount, which was rated by Celestron for 65 pounds, and I really wanted a Newtonian because I've owned some Schmidt Cascades in the past, and most people don't make Newtonians in this size, not commercially. So I said, I'm going to go ahead and build my own, and picked all the pieces up and put it together like Legos or Lincoln Logs or whatever people build with nowadays. And I've added some little things to it along the way, but it's essentially a 14-inch f4.5 mirror that I got from Carl Zambuto in a tube made from a guy here locally, Joe at Parallax Instruments, built a tube. And then you just put focuser, secondary mirror, spider vane, all that kind of stuff into it. It's I never thought of myself as an amateur telescope maker. You know, the ATM moniker just never struck a chord with me. I never really felt like a do-it-yourselfer. But it was very much an enriching and empowering procedure to go through. I've never looked at myself and gone, yeah, I'm going to go do this myself. I had this vision in my mind. Actually, I will say I followed Anthony Wesley's lead on a lot of this kind of stuff. Anthony's a big Newtonian guy. He's done a lot of planetary stuff, and he's been a big inspiration in a lot of different aspects. So most of what I have is really kind of either robbed directly from his own ideas or borrowed.
Yeah. Now, one of the reasons why people get into amateur telescope making, though, is to try and save a little bit of money. So, do you think you saved any money building it yourself?
Fortunately, I guess I didn't total it up that way. It comes in piecemeal, right? You pay for this one this month, pay for this one the next month. But really, it probably was a wash, and it may have been slightly more expensive. But I got some things that I actually really wanted. One of them was the focuser here, and I'll pull the filter out. I don't know if you can maybe point it up just a little bit higher here for a second. The focuser is a motorized focuser, and it was one that Anthony had that I can control from my computer, because focusing is one of the trickiest things to do, and I actually think there's some advantages to having a motorized focuser that you can drive from the PC, because you can sit and watch the live display, and it moves in and out with keyboard strokes, as opposed to having to stand here and twist the knob, because as soon as you touch the knob, the whole thing starts shaking, and it's kind of almost counterproductive to do it that way. So, I got some extra things that I probably wouldn't have if I had just gone with the stock, off-the-shelf telescope. So, you can't sit and compare if I bought, a C14 like Gary has, or, a Meade equivalent. It wouldn't quite be the same, I think.
Yeah. Oh, it's a phenomenal setup.
That's quite a setup.
And you've really geared it for doing planetary work.
Yeah, I have, and one of the things that I did just recently add to it was I think it's the same camera that Stuart has here. It's the image source camera, and it's a color one. I got a color one so that I could give you color when I shoot planets.
Nice.
I just need some clear skies now.
You did that for us.
I did that for you, and it was kind of twofold. It was a little bit selfish in the regard that I stuck it on the finder here, and I have intention to try to do some guiding with it, to try to do DSO. I have a nice little Canon digital SLR that is a little underutilized for astrophotography. I just got to buckle down and find some clear skies and some time to get it to do that.
Yeah.
So hopefully I can do twofold with it. I like to be able to do planetary, which is really what I built it for, but if I can also do some deep sky with it, I'd like to be able to do that. So time will tell.
And it's a great system. I can't plug this enough, and I'm so sad that YouTube accidentally didn't upload our video quite right. You have a great system for observing orbiting asteroids and actually watching them move against the background stars.
Yeah, that was pretty neat.
All right.
It was a surprise to both of us, too. I think
Yeah.
I don't think I found out until the next day there was a second asteroid in that field.
It was just fabulous to watch.
Yeah, that was pretty neat.
Well, why don't we take one more quick view over at Gary again? Is that the Ring Nebula? No.
No, that is M46, which is an open cluster. And in the middle right here is the Rotten Egg Nebula.
Is that what it's called? The
I'll
Rotten Egg
zoom
Nebula?
in.
I remember the first time I saw that cluster, and I was completely astounded that little thing was lurking there. I was like, that is so cool.
It's just a random planetary?
Yeah, right next to the globular cluster. I guess it's in the foreground?
Well, no, it would be in the background.
Is it? Okay.
No.
Yeah.
The planetary nebula would be a lot closer, right?
No, why?
Well, but I guess the point is it's not part of the cluster, right?
Yeah. Yeah, it's not part of the
So that's the Rotten Egg.
Rotten Egg. That's cool. That's an interesting name.
So an open cluster is basically what the Orion Nebula is going to look like in 10, 15 million years. It's a system. Actually, that's too much time. It's what it's going to look like in a few million years when all of the star formation is done. And it's had a chance to orbit around the disk of the Milky Way a couple of times and slowly start to spread itself out. And over more and more time, the stars are going to get spread more and more until you can no longer tell that there's this overdensity of stars. Or it could just get eclipsed by the view of a telescope.
And while we were talking about guiding, this is my scope. This is my guide scope up on the top. And this is, let me grab it here. This is the program I use for auto guiding. So it's just running at 1 second exposure right now. I find a star in the field, click on it, and it will come up, and I say stop and guide. Now it will continually, at a 1 second interval, it'll move my scope just a little bit to try to keep that star right in the crosshairs.
And by keeping that star in the crosshairs is keeping the main telescope pointed at whatever it was pointed at.
Right.
Yeah, and so this is the trick, to get these really, really long duration, really crisp, clear views. You've got to have that second telescope that's just guiding on one star.
Yeah.
And it's a pretty clever piece of technology, but I guess you got to go out and buy another telescope, right? And bolt it on the side of your main telescope.
I went the finder scope route.
Yeah, a lot of people use their finders.
So we'll see. Yeah, I mean, I don't know if it's going to be as accurate over time with enough, with enough error in your polar alignment. But Gary, yours is in an observatory on a pier though too, right? Which helps
Yes.
because you're polar aligned and you don't really have to touch it.
I leave
you
it
move
polar
from
aligned
object
and
to
don't
object.
play with it.
Right. You move from object to object fast, and sometimes I even struggle just finding a guide star.
I understand, and that's why I have a paired observatory. I got tired of that.
Yeah. Yeah, as Stuart is, moving around his property to try and get us a better view of Saturn, I'm sure he's liking the idea of a permanent mount. Yeah, you see, I think that's definitely a good investment at a certain point. If you've got a nice telescope and you want to do a lot of observing, a lot of the high-end astrophotographers have these permanent mounts. They've got their own little domes. It's a pretty great setup.
And it's really not that expensive. That little pod that I got isn't bad at all. The shipping's more than the unit is.
Yeah, it's seriously, this is the type of thing where road trip is totally worth it if you can get a big enough pickup or a U-Haul truck.
Yeah,
Yep.
Go pick one up. All right, and then last but not least, we've got Roy Salsbury, and you've plucked one of your babies from their home and brought it home?
I brought it home so that I could do these star parties. But I haven't got it set up yet out back. So I'll only be able to get planetary stuff with it. There's just no way I can get long exposures in the middle of Las Vegas.
Yeah.
I'll be able to get some planetary stuff, Mars, Saturn, hopefully.
Mm-hmm.
So the one thing that I was going to say on here, I don't know if you can see it very well. This right here is the focuser. So it's the, just like Mike was saying on his focuser, whereas this one here moves the mirror inside. I've got a microtouch wireless focuser on this one, which basically just turns the knob for me.
Right, and so you can focus it electronically, right?
Correct. I can
Yeah.
focus this electronically and use the software to do focusing runs. So after every 15 minutes or whatever, it'll do a separate focusing run, get everything perfectly focused. But I was going to try. That's the scope that I brought back with me. That's my 8-inch Celestron. It's usually out on a wedge out in my observatory. Here is the other one.
And this is real. This is right now.
This is right now. It's sitting in my observatory with the roof closed because it's not quite working because I have a portion of it off getting hyper-tuned. So
Hyper-tuned?
Hyper-tuned. It's getting all the bearings re-greased and ceramic bearings put in it and a bunch of cool stuff.
There's lots of minor things you don't think about, like different materials have different thermal conduction properties. They expand and contract differently with the temperature variations. And when they're manufacturing these telescopes, they're trying to make them as affordable as possible. But after a while, you want to just invest the extra money to get higher quality bearings and gears, to beef up the ability that your motor has to very carefully move your system with those heavy cameras on it. And there's a lot of really good guys out there who've invested the time to figure out what do you need to do to soup up your telescope the way people used to soup up their muscle cars. And it's really worth it because the glass is where the bulk of the expense is.
Yeah. So it's getting fixed up, and it's a good thing because the summer months out in the desert are very, very hot. So I wanted to make sure I had all the grease replaced, new bearings put in it. But the telescope on top is a 6-inch or a 106 millimeter refractor. And then there's a CCD camera on the end of it. On the other side of that camera, or that telescope is another 66 millimeter refractor, which I use for my guiding.
Do you think you could ever get to the point where you could be doing this remotely?
Oh yeah. I'm in the process right now, and let me switch this off.
I mean, really, the only thing that's connecting Gary and his telescope is a wire, right?
Yeah.
That wire could be very long.
I'm in the process of, I've bought a bunch of microcontrollers, so I'm in the process of writing the software and writing all the electronics, or hooking up all the electronics to automate my roof.
That would be great.
So I will be able to, from here in Las Vegas, open up the roof and take pictures whenever I want.
Oh, that's going to be amazing.
Yeah, so it'll take me a couple of months to get it done, but I'm hoping by the end of the summer to have it done.
I'll tell you what, though, Roy, you're motivated to do it. If rolling the roof off is the only thing you have to be there for, which is probably frustrating. Like, if only, you know.
Oh, yeah. Here's the observatory.
Oh, that's beautiful.
That's not a live view, though.
No,
Yeah,
no, that's not a live view.
Right, right.
He can give us the live view, though.
I could give you the live view, but it's
Pretty dark, right?
it's a little dark. You'd only see the infrared cameras.
The only trick is to have a system that knows when it loses all battery connection or internet connection, not battery, all power connection or internet connection, it needs to use batteries to close the roof. This is the one issue, is you never know when you're going to have sudden technical difficulties. Out at McDonald Observatory, there was one time I was observing, and we lost the power in the most profound way, because we lost one of the phases, and then we lost the rest of the phases, and it destroyed everything, smoke going through the building, and the dome was still open, and I didn't know what to do, and I wasn't going to leave the telescope with the dome still open. I got mocked later because the building was full of smoke. But it turned out that there was a set of car batteries that you just have to know what switches to turn, and the thing is, you don't want to get rained on because this is an investment that's hopefully going to bring a lifetime of observing.
So
That's
I'm
a live
getting.
view of the observatory.
Oh, that's cool. You can still see it. So I'm hearing from some people in the comments that the view is stuck on Roy. Now, right now we've actually got the view stuck on Roy, but I'm going to do a test here, and I'm going to go over to Gary's view right now until we get whatever it is that Gary's got here. And I want to know if this is switched for people, or is it still showing Roy's setup? Because I'm wondering if, because when I crashed out of the Hangout, it now is wrecked.
So everybody's just been looking at me.
Yeah, the whole time. which might mean that we'll have to end this. But I think we're sort of reaching a natural end pretty shortly anyway. So if people in the comments are watching this, if someone could just mention whether or not they're able to see Gary's view as the big one right now. I've selected it, but I'm not sure.
On CosmoQuest, I'm still seeing Roy's.
You're still seeing Roy. Yeah.
Scott's telling me they're still stuck on Roy's.
Yeah. So I'm guessing that's a bug from after I crashed out of the Hangout. It's now stuck. So
yeah, and for those of you over on CosmoQuest, I have to apologize for the comments. It turns out there was a change in how the comments are handled between Wednesday and today, and I will be working to fix that.
Yeah. So then I guess people are gonna see Roy's dome, Roy's observing area, but there's a tiny little thing that we're looking at in Gary's view, and so why don't we get a quick explanation of that, and then I think we'll probably have to wrap this up.
This is the monkey head?
Yep, we looked at first last week, and it is the monkey head, and if I rotate it left, no, now I'm out of frame. There we go. You can kind of see Pamela pull the monkey head out of this.
Like the profile,
so over to the right in the itty-bitty little tiny window no one can see, there's a nose and then an eye above it and a stripe going across the cheekbone, and then all these tendrils of clouds I see is a little tamarin's hair.
I want you know what? I'm sorry, Pam. Sorry to interrupt. I want to try one quick experiment, which is I'm going to kick Roy out.
Okay.
So Roy, can you drop out and then try coming back in? And
Yes, I can.
fix the problem.
Nice knowing you, Roy.
All right. Yeah. I'll try to come back.
Okay. Now Roy's leaving, and so now Can the people who are, or Scott, if you're watching this right now, can you tell me if you're able to see Gary's view as the one that's highlighted?
I'm waiting for a message for Scott to let me know.
Yeah, Scott's typing right now. He sees a white screen.
Oh man.
No quest.
Total death.
Completely
Total
white.
death.
But Scott, you can hear us. Okay, well at this point then, I am going to say that this hangout is over.
And we will return to the monkey next week if we can.
Yeah.
It is an Orion, so it's getting low on the horizon, but it's higher than
And
the
I
other
ju-
ones.
but I just got Saturn.
I know. No one can
What
see
happened to
it.
me the last time?
Saturn, for those of you, I guess for everyone who can't see us, Saturn looks amazing.
Well, it's down there in the bottom right corner.
Yeah, it looks really great. So I'm going to click on it, and hopefully that gets recorded in the final hangout. So that's
Thank you
fantastic.
everyone for all of your patience. This virtual star party has been hosted by Fraser Cain with support over on CosmoQuest, where we are working to refine our code all the time, and hopefully we'll bring it up to date with all of Google Plus's changes. Our next virtual hangout is going to be tomorrow when we record Astronomy Cast, and that's going to be at noon Pacific, 3 p.m. Eastern. And if you got the CosmoQuest newsletter, it lists a link to all times for all time zones. If you didn't get the newsletter, you need to sign up for an account over on CosmoQuest, and you'll get an email every Sunday that lists all of our upcoming events. So we hope to see you tomorrow at 2 p.m. Central in my time zone, or noon Pacific. And you'll get to hear all about this crazy universe we live in. After that, we have Wednesday at 4 p.m. Pacific, 7 Eastern, the weekly science hour, and then Thursday morning at 10 a.m. Pacific, noon Central, 1 Eastern, we're going to have the weekly space hangout where we bring you a roundup of all of this week's news from the newsmakers from MSNBC, Discovery Channel, Universe Today, and a variety of other places. So thank you for being here, and join the conversation over at cosmoquest.org.
So smooth.
Thanks,
All right, well, thanks, everybody.
Good night.
We'll see you guys next week.
Good night.